Hey there, and welcome to Doing Things Dan's Way. So I'm really excited for today. Today I'm finally going to upgrade the power system in my old trailer. This is a 1990s era tow light. It's one of these that has the top that goes up and down. And like a lot of old trailers, it just has an old-fashioned power system. It's a 12-volt heavy lead-acid battery, and it's got a charger in it that will charge up when you plug into wall power. Of course, when you have power at your site, then the outlets in the trailer work. Otherwise, forget it. You can't use any appliances because there's no inverter. So today I'm going to be installing a lithium iron phosphate battery from OKMO. I'm going to be installing a transfer switch style charger converter, inverter, and also a solar input so I can be basically off-grid permanently with this thing and still have AC power. If you want to watch that, don't go away. This is Doing Things Dan's Way. So if you're familiar with these older trailers, you recognize this. You got a typical propane tanks and a big old 80-pound lead acid battery up in the front. And of course, this has to be up front. It can't be inside because this thing puts off hydrogen gas while it's charging. The new iron phosphate batteries we're going to install can be put inside because they don't produce those gases. So that's an advantage. Obviously, this thing weighs about 80 pounds, and that's pure tongue weight here. The new lithium iron phosphate batteries from OKMO, those batteries, not only can they go inside, but they only weigh about 24 pounds compared to the 80 pounds of this guy. Just getting this thing out of this box is something that I almost need help with. Okay, so these are the basic components of the system that's going to go in the RV. So start all off, this is the OKMO 100 amp hour 12 volt battery. This is like 24 pounds compared to a lead acid being 75 to 80 pounds. So it is a breeze to work with. You can pick it up with a couple fingers. It has a strap that comes with it. Just amazing how these lithium iron phosphate batteries have dropped the weight of these systems. Okay, so I'm in my office for a second, and if you know me, you know I take everything apart. Brand new things, take it apart to see how they're built, what chips are on the board, just the quality of it, all that kind of thing. So I ended up getting a total of 4 of these OKMO batteries, and this one came with a box just wrecked by UPS or FedEx, whatever it was. It was bad, but I'm not mad because it basically bashed the top off this thing, and it mangled it up a little bit, but it gave me the opportunity to look inside. So take a look inside. Okay, so it wasn't completely off when I got it. I had to do a bunch more prying, and the battery's a little worse for wear. But take a look inside. It's really, really interesting. I've seen a number of these being torn down and cut open. Will Prowse, amazing dude. He's done an awesome job of reviewing batteries. This one's interesting because what they've done is they've completely epoxy coated the entire inside of this, right over the top of everything. Not so much the wires, there's a little bit of residue here, but the whole thing, there's foam on the sides. The whole bottom, looking down inside, is basically filled with resin, like up to here. And so this thing is not going anywhere, which tells me you can mount this any which direction you want to. So this side back here, the batteries are actually facing this direction, and the terminals are on the top here. So let me flip it around so you can see that. So I'm not sure exactly how well this is going to show up on camera, but this up here, these are the big plates that are going from cell to cell. So like there's one jumper right here. There's another jumper here going down to the other side. And they doubled up, basically, the connections going to the BMS up to the terminals that are on the lid, basically, where you screw into this thing. And you can see there's a fair amount of space left and right, front and back. So even though this thing was kind of hit on by the shipping, it didn't actually get into where the cells are. And so I feel very comfortable with this battery, even though it's kind of got smacked. I think it's very, very safe as is. Now, of course, the other nice thing is if you're using this for a marine application, is having all the terminals and the BMS basically sealed in with the epoxy tells me that I'm not going to have to worry about any kind of rusting or corrosion in that kind of environment. And looking here at the terminals, they have really, really nice swaged connections. You can see the way these are put together. And then again, the fact that they doubled it up. Instead of using one big huge wire, they used a couple. And so that seems like a good idea. And over here on this side, we can see the output leads from the BMS that are going to go and attach to each one of the different cells. And again, because the whole thing has been covered in resin, these wires are all basically stuck hard to the side of the battery. which is kind of holding them in position really nicely. So that's great. So now that we know what's going on inside the box, let's look at the other pieces in the system. So the next big thing, of course, is the inverter. Now this is a low frequency inverter. It has a big monster transformer in it, and that's just a style. You can get the high frequency styles, which are much smaller. I picked this one up, and it's a 2000 watt, has a surge rating that's at least 4,000 watts. It'll start up anything. The next big box would be the solar charger. So this is an EPEVER unit. You can get these in 20, 30, 40, 50 amp versions. I think this one's a 30 amp version. One full size residential panel at 350 watts or so, or even 400. This could handle no problem. Otherwise it could handle a series of other smaller panels. What's positive is going to the inverter with a nice big fat 0-aught cable. And you need something fat like this because you're going to be putting out easily 100 amps in a system like this. And so you need these big, finger thick wires to handle the heat and not drop voltage over the length of the wire. So these wires need to be as short as possible. The other pieces of this puzzle, on the negative side, we're going through a 150 amp breaker in this case, and it could easily go to a 200 amp breaker. The whole point is in case we get a short circuit out here somewhere. The next piece is a big turn switch style disconnect, so I can shut off the batteries completely. If I want to, if I'm done using the trailer, I could just shut it down entirely. So this is a current shunt. So basically it's a very, very low impedance resistor, like a milliohm. So it doesn't drop a lot of voltage across here, but this value is being sensed and brought to this display. So this display is showing us a picture of the battery, is showing us the amount of amp hours that are contained in the battery. Right now it is full, it's a 100 amp hour battery. And so it's sitting at 99, it's saying it's 100%. And if we're charging, it'll say what the wattage is of charging, and if we're discharging, it'll say what the discharge current is as well. So I hope you get the basic idea here. You have power that's stored in the battery. We have an inverter that takes the 12 volts and converts it up to 120 volts AC and puts it out. So this is the input and output on the AC. And this is also a charger, by the way. So when we plug into the wall with the RV plug, outside when we're out camping or when we're back at the house, this will go from taking battery power and making 120 out of it. It'll switch the 120 over to, basically it'll just connect these two lines together. So now the appliances in the trailer, in my case the fridge, will be powered directly from the wall. And this will go into fast charge mode and will quickly charge this battery. This one can charge, I think it's 60 amps or maybe 80 amps or so. So it'll put at least 1,000 watts into the battery and go through the profile to charge the battery up perfectly. I've been working on this, so it looks like a mess right now. But let me show you what I have going on. So I have 3 of the OKMO 12 volt 100 amp hour batteries here. So that's going to give me 3,500 watt hours of power. I have a solar charge converter that's going to connect to these. And then I have a 2,000 watt low frequency inverter, which is also a charger, and it's also a transfer switch. So this will take the shore power and power all the outlets in the trailer, as well as charge the batteries. And then automatically when I lose shore power, when I unplug, the inverter will turn on, take the DC and convert it to AC and power all the outlets. If you'd like to see the full process of building this whole system, the time lapse represents about 15 minutes of footage. And that footage can be seen in the video that's linked down below, which has the full version of the build on this trailer. Over here, everything is looking good. So the batteries are all together and happy. The solar charge converter is mounted. The breakers are in. Charge manager is in, which basically tells us state of charge and current power coming and going. The switch is in, so we can come down here and just flip the whole system off if we need to. And that is available. Let's see, what else do we have here? Of course, the inverter's in and mounted. Displays are working fine. Right now it is showing we are consuming 35.9 watts right there. And the Renogy needs to go through a full charge cycle to see the batteries top off, and then it'll know that it's fully charged. And then the solar charge controller, of course, is there. And that is looking good as well. So that's kind of maybe an awkward spot to have them. I can just look in here and take a peek and, okay, there's my values. Okay, looking good, okay. Well, good morning. It's a cold one. And I just wanted to show you a little update here. So the trailer is up and running. I've got a couple panels out here that are keeping it status quo. And looking on the inside, it's basically all back together again. I have that out for the moment, but looking down here, we have the battery fully charged. Just sitting here, it's consuming about 31.5 watts. That's just the inverter running, and maybe something else. The fridge is actually on but not running at the moment. And you can see the solar panel is in, but it's in the shade, so it's only at 14 volts. It's actually 14 volts, 0.2 amps. So it is actually trying. Even in this, low, deep shadow, it's still producing a little bit of power. So this is basically able to keep this trailer up and running continuously, 24/7, with that amount of panel, that amount of battery, and everything up and running. So that's a wrap on this project. I really like how this came out. It looks like a really clean install. I'll have links, of course, below in the description for all the products that I use, including any discount codes I've gotten from manufacturers on those. Videos up here are other things I've done on power systems. Hit those up, smash my face, give me a thumbs up if you appreciate it, and comment below any questions you have about the way I put this together. I'm here to answer questions and to talk about your system if you're interested. Until next time, guys, be blessed. Know God loves you.